Hello friends, welcome to our channel, and our next chapter is seepage analysis. So your first question is, a flow net is drawn to obtain what? Seepage coefficient of permeability, not coefficient of permeability, so this is not correct. Coefficient of permeability not correct. Exit gradient सही है. Then uplift pressure, then seepage quantity, ये सही है. Answer C. Next question, a uniform sand stratum 2.5 meter thick has a specific gravity of 2.62 and a natural void ratio of 0.62. The hydraulic head required to cause quick sand condition in the sand stratum is how much? So given data are, our thickness of the stratum is given 2.5 meter. So L is 2.5 meter and specific gravity is given G equals to 2.62 and void ratio E equals to 0.62, and we require the head H value. So for quick sand condition we know that critical I exit gradient, that will be our exit gradient. So ICR equals to, we know that formula, G minus 1 divided by 1 plus C. So G value 2.62 minus 1 divided by 1 plus 0.62 and it gives 1. Then ICR equals to I, that is equals to 1, and ICR or I equals to H divided by L, that is head divided by length. So head, we require this head, L is given 2.5 meter. So this answer will be 2.5 meter. Next question, quicksand is not a type of sand but it is a condition arising in a sand mass. Assertion is given and region is given. Assertion that is correct assertion that quicksand is not a type of sand. quicksand जो होता है ये sand का एक condition है, not that is a type of sand. So ये सही है. And region क्या दिया है? When the upward seepage pressure become equals to the pressure due to submerged weight of soil, the effective pressure becomes 0. ये उसका रीजन भी सही है. सो दोनों assertion and region are correct. Next question, which relation is correct? Okay, so IC equals to G minus 1 whole into 1 minus N, ये सही है. Next question. Okay, next question, this is a flow net is given here in the figure, and the question is that you have to calculate the head at point A. So A point पर head कितना होगा, and also question is given total head is 18 meter. Okay, so total head is given 18 meter and we have to calculate head at point A. So first count number of drops. Number of drops कितना है? 1 2 3 4 5 6 7 8 9. No, 9 number of drops are given. So total head is 18 meter. Total drops is 9. So per drops, what will be the head? 18 divided by 9. 18 divided by 9, that will be 2 meter of water per drop. And A point is given. A point कहाँ पे है? ये 1 2 3 4 नंबर पर है. इसका मतलब टोटल 18 मीटर था हमारा हेड. तो यहाँ पे कुछ लॉस हुआ. कितना लॉस होगा? एक ड्रॉप पे 2 मीटर ऑफ वाटर लॉस हो रहा है, तो इधर 2 मीटर वाटर लॉस हुआ, प्लस इधर 2 मीटर ऑफ वाटर लॉस हो गया, प्लस इधर 2 मीटर ऑफ वाटर लॉस हो गया. तो कितना लॉस हुआ टोटल? 2 + 2 + 2 2 2 4 and 2 6. यहाँ तक आने से पहले 6 मीटर ऑफ वाटर लॉस हो चुका है ऑलरेडी. तो 18 मीटर था और 6 मीटर ऑफ वाटर लॉस हो गया, तो ए पॉइंट पे बचा कितना? 12 मीटर ऑफ वाटर. सो इट्स आंसर विल बी 12 मीटर ऑफ आंसर बी. नेक्स्ट क्वेश्चन, which one of the following equations correctly gives the relationship? ये रिलेशनशिप जो दिया है इसमें से कौन सा करेक्ट होगा? सो ये G एंड I के बीच में जो रिलेशन है, तो हमारा ये रिलेशन क्या था? IC that is equals to G minus 1 divided by 1 plus E, this one, and G equals to क्या होगा? G equals to होगा IC and E void ratio is given 0.5. Void ratio is given 0.5, so E value 0.5. So here G equals to, here next IC equals to G minus 1 divided by 1 plus E. Next IC equals to G minus 1 divided by 1 plus E value is given 0.5. Void ratio is given 0.5, so this one will be 0.5. Then this will be G minus 1 divided by 1 plus 1.5, and G will be 1.5 into IC plus 1, यहाँ था -1 तो इधर आ गया +1, so this will be 1.5 I plus 1. This one. Next question is, a sand deposit has a porosity of 1/3 and its specific gravity 2.5. The critical hydraulic gradient to cause sand boiling in the stratum will be how much? Sand boiling means critical condition. So critical condition formula, that is, we know that ICR equals to G minus 1 whole into 1 minus N. So N value is given, G value is given, put all the value and answer will be 1. Next question, a flow net constructed to determine the seepage through an earth dam which is homogeneous but anisotropic gave four flow channels and 16 equipotential drops. The coefficients of permeability in the horizontal and vertical directions are 4.0 into 10 to the minus 7 meter per second and 1 into 10 to the minus 7 meter per second respectively. If the storage head was 20 meter, then the seepage per unit length of the dam would be how much? Seepage per unit length of the dam means Q के वैल्यू पूछा है, टोटल सीपेज कितना होगा, टोटल डिस्चार्ज कितना होगा, Q की वैल्यू पूछा है, और गिवन डाटा दैट आवर सॉइल इज anisotropic. So in this condition, all the given data are number of flow channels is 4, number of drops is 16, and Kx permeability in the x direction is given, permeability in z direction is given, horizontal and vertical. Then H total head is given 20 meter, and for anisotropic soil our Q value equals to discharge Q equals to K dash NF divided by ND into H, and K dash, how can you calculate that? Kx into Kz whole root. So put all the values and answer will be 10 into 10 to the minus 7 meter cube per second. Next question, the configuration of flow nets depends upon. Flow nets जो बनाते हैं वो किस किसके ऊपर डिपेंड करता है? The permeability of soil. Not this one is wrong. Then the difference in head between upstream and downstream side. No, this one is also wrong. The boundary condition of flow. Right, this one is the correct answer. The amount of seepage that takes place. No, this one is also wrong. So the boundary condition के ऊपर सिर्फ हमारा flow net depend करता है. Next question, from a flow net which of the following information can be obtained? Rate of flow, right? Flow net से हम लोग rate of flow निकाल सकते हैं. Discharge Q, that is, निकाल सकते हैं, ये सही है. Then pore water pressure, ये भी सही है, ये भी निकाल सकते हैं. Then exit gradient, ये भी निकाल सकते हैं. I वैल्यू निकाल सकते हैं ना. Next permeability नहीं निकाल सकते. So answer will be 1, 2 and 3. Answer will be B.